let's talk about the 45-degree angle, sine, cosine, tangent of 45 degrees. Well, the way to do this is to start with a geometric object that has all sides the same length. And that object, in this case, the one that's going to be useful is a square, right? So I draw a square like this, and I'm just going to pick all four sides to be length 1. I could pick a different number. I could pick 3 on all four sides. I could pick 28 on all four sides. I'm just going to pick a 1 on all four sides, right? So that's my picture with the ones labeled. For instance, one thing I could not do is I could not pick a square and have the lengths be 2, 3, 4, and 5. That doesn't make any sense, right? So let me cross that out. Okay, we've got this square where each side is length 1, and then I'm going to cut the square in half. I'm going to draw on a line somewhere, a line segment that's going to cut this in half. What's going to be convenient in creating a right triangle is to just draw from one corner to another. I could do this way or that way. I'll just pick one of those. And so we got that right there. So that, let's label that unknown side. How about, I'm going to use an m. It's not a very often used variable, right? In this, people often want to use x or y, and that's fine, but I'll just use an m. And the point is, I'd like to stare at in the lower right, so half of the square, you know, when you cut this like kind of sandwich style, right? Like there's this right triangle here. Like maybe I'll label this. Why don't I label the vertices, right? So I mean that. And in that, so there's a right triangle. A side is known, another side is known, and the hypotenuse is not known. So we can use the Pythagorean theorem and have 1 squared plus 1 squared is equal to m squared. Right? So in a right triangle, you know 2 sides, then you can get the third side somehow, right? So in this case, the variable side is the one that's the hypotenuse, so that's on the side by itself. And we'll simplify the left side, 1 squared plus 1 squared is a 2. So 2 is equal to m squared. Square root both sides, you have a plus or minus root 2 is equal to m, but we're talking geometry. So the variable shouldn't take on a negative value since we're talking about a length. So we'll get here that m is equal to root 2, okay? Cool, like that. So if we draw, maybe just to try to make things clear, let me just draw the half of the square that I really want to talk about. So sorry for the redrawing, but I do hope that that's helpful. So from this picture, I hope you see just from like how things are tilted what I was trying to do. I'll just label the, you know, the 1 and the 1 that we knew, but the root 2 that has just been newly discovered. Now we have all 3 sides, and let's go back and argue that in this picture, and we could argue this point earlier than we did the Pythagorean theorem, okay? But there's this 90-degree angle over here too, right before this cut occurred. And this cut goes directly halfway across. So we've got a 45-degree and 45-degree angle. So let's label that 45-degree angle down here, right? So 45, ooh, I don't know if I have quite the room to do that. Sorry, but 45 degrees there, 90 degrees there, and another 45-degree there. And the point is, based on this 45-degree angle, we can now compute, since we know all 3 sides, we can compute sine, cosine, and tangent, right? So sine of 45 degrees is, it's supposed to be opposite over hypotenuse, so that one there over root 2 there. So 1 over root 2. And then cosine is adjacent. So cosine of 45 degrees, this adjacent one over the hypotenuse root 2. Cosine of 45 degrees is equal to 1 over root 2. And then finally tangent, right? So tangent should be opposite over adjacent. So what, this one over that one, tangent of 45 degrees, let's not forget the degree symbol, 1 over 1. All right, so now all 3 of these fractions simplify. I mean, the 1 over 1 is really easy, right? That's just gonna be 1. Now, the sine value, sine of 45 degrees, cosine of 45 degrees, they both happen to be 1 over root 2. But let's just take one of those. I've just, you know, I've got like 1 line of space down here. So why don't I'm just going to write down that fraction, 1 over root 2. And we can rationalize the denominator. So we're going to multiply by root 2 on top and bottom. I'm going to multiply by the same thing on top and bottom. So root 2 on top, root 2 on bottom, like that, right? Actually, I should have modified what I had there existing. So sorry, I've got a little space in front. I'll just do this. So we started with 1 over root 2. What you can have that fraction value being equal just by multiplying by the same thing on top and bottom. In this case, multiplying top and bottom by √2 is going to help. And so then let's simplify that. Multiplying straight across, got a √2 on top. On bottom, √2 times √2 is going to be a plain old 2, not inside a root. And so that's the traditional value given, right? So sine of 45 degrees is √2/2. Same for cosine of 45 degrees. That's also √2/2. And tangent of 45 degrees is equal to 1. Just to review, we started with a square. By drawing in the diagonal, we were able to argue that this 90-degree angle that was in the lower left corner should be split into two equal-sized 45-degree angles. That lower 45-degree angle was labeled there. We just decided to use ones all the way around. So that's why there's a 1 squared plus a 1 squared equals, and then this unknown diagonal was the hypotenuse of that right triangle, right? So we applied the Pythagorean theorem, did a little bit of algebra, got that hypotenuse side to be √2. And at first, we only knew 2 of the 3 sides. Now that we know all 3 sides, we can compute these trigonometric values. So there we go.